And break up the limit. This is not the distributive law. I'm not distributing this operator to these two. I can say that the limit of a sum is the sum of the limits. And because I know them, I'm going to write L plus M. So the limit of a sum is the sum of the limits only if these two exist. In other words, if they're numbers. If they're infinity, no. I can conclude that. I cannot use the limit law. I'm going to put both limits, the sum and the difference, in the same law. So what am I saying here is this. If I calculate the limit of a difference, and these two limits exist, then I have the difference of the limits, which reduces to L minus M. Same thing for the product. Same idea. So number 2, limit of f of x multiplied by g of x as x approaches a from either side. I can break this one up as well, as long as a limit of f of x and limit of g of x exist. If they don't exist, I cannot apply this rule. So if they do exist, and I know that this is L and I know that this is M, this will be L times M. Of course, the same idea with the ratio. So limit of f of x divided by g of x as x approaches a. This will equal the limit of f of x as x approaches a over the limit of g of x as x approaches a, assuming that the limits exist, and definitely m cannot be 0. Because we know that division by 0 is undefined. This is what we call undefined. So for example, 5 divided by 0 is called undefined. The function does not exist when the denominator is 0. Number 4, the limit of a constant as x approaches a is the constant itself. I don't think that this should be a limit law, but it's common sense, but it's considered a limit law. So then, limit of a constant multiplied by f of x as x approaches a from either side. The constant can go in front as a factor. So this will be c times limit of f of x as x approaches a, and now I can write c times L. Okay, so one more. Basically, there are two, but they can be written in the same limit law. It's all about powers. So limit of f of x raised to power m as x approaches a. This is an important property because it allows us, I should mention, it's under certain conditions, and the condition is, we haven't discussed it yet, but it's under conditions of continuity. We can, or we are allowed, if you like to write, it's better, we can swap the operators. What does this mean? What operators? What am I talking about? I'm talking about two operators. This is one, and this is the other. So the power is applied to the function first, and then the limit. Well, I can reverse that. I can apply the limit first, and then the power. I swapped the operators. I changed the order. the power was applied first, and then when I'm done, I apply the limit. But I can, under conditions of continuity, I can swap the operators. So I can apply the limit first, and then the power second. The same thing with the nth root, or the mth root, right? So the limit as x approaches a from the mth, or n, you can use n in both, it doesn't matter really, of f of x. Again, I can swap the operators under the same conditions. So the root is applied first, and then the limit. But now, I can apply the limit first to the function, and then apply the root. So here we assume that m is an integer, m integer. And of course here it has to be a number greater than or equal to 2 because it's an index, of course. So let's calculate few limits, not before we talk about the limit of a polynomial and the limit of a rational function. So if I have a limit of a polynomial as x approaches a, I simply replace it. Replace x by a. Well, this is a contradiction. So you could say you are contradicting yourself. And I will have to agree with you, because I specifically said that x does not equal a. When we say x approaches a, we really mean x does not equal a. But yet, right now I told you to plug in, replace x by a. It's not a contradiction, only because we get to the same result. So for a polynomial, this is okay to do, because polynomials are defined everywhere. So there's never a problem with a polynomial. So this is for polynomials. Also for rational functions. We can do the same thing. So if I have a limit as x approaches a from a polynomial divided by another polynomial, p of x, q of x. This is a rational function, a polynomial divided by another polynomial. I can write p of a over q of a only, there is an only here, only if a is in the domain of this function. In other words, q of a does not equal 0 in the domain of p of x divided by q of x. So it's the same situation. Like with the polynomial, as long as the denominator is not 0. And now I would like to look at a couple of problems before we address continuity. So now we are on page 113. And please feel free to select. I just selected a few. It doesn't matter. You can choose anything you want. So the first set is asking us classify each statement as false, true or false. So we can select anything, but not the continuity or discontinuity yet. We haven't talked about that yet. So from among the first ones, any questions? Any questions for me? Anyone, please? Always stop me if you have questions. Don't hesitate, please. Okay, so here's the first question, number 1. We are on 113. And this is limit of 7 as x approaches 3. They say this is 3. Is that okay? Is that acceptable? Is that true or false? Anyone? Of course. Thank you very much. What about number 3? It says limit, given that limit of g of x when x approaches 1 from either side is 5, can I draw this conclusion that the limit as x approaches 1 from either side from g of x squared is 25? Is that true or false? True or false? Anyone? Absolutely true. Because we swap the operators if you want to do that to apply the limit law. So I will have limit of g of x as x approaches 1. I know that this is 5, so then 5 squared will be 25. Very good. Okay, so let's look at other types of problems. Not with continuity just yet. So we're given some polynomials and rational functions. So let's look at problem 14. Let me know if you want to choose. So this is limit as x approaches 3 from either side of x squared minus 4x plus 7. So I know that this is a polynomial. I will plug it in directly, and I get 9 minus 12 and plus 7. 9 plus 7, or if you want 9 minus 12, it doesn't matter how you do it. So 9 plus 7 is 16. 16 minus 12 is 4. So I was allowed to do this to simply plug it in because this is a polynomial. The same thing with 18, which is limit as x approaches 3 from either side from x squared minus 8 over x minus 2. I will plug it in. And moving forward, I want to say we will always plug it in to see the type of limit. So when I plug it in, I get 9 minus 8, which is 1, and 3 minus 2, which is 1, so the limit is 1. So why I got a limit? Because 3 is in the domain of this function. What is not in the domain of this function is x equals 2. But 3 is in the domain of the function, so by simply plugging it in, I get the limit. Now, any questions for me?
No.
Thank you. Now I'm looking at problems from 19 through 36. No, first from 19 to 30, and then 31 to 36. So let's look at problem 22. Limit as x approaches 1 from either side from x squared plus 5x minus 6 divided by x squared minus 1. So the same thing I need to do. Every time I calculate a limit, I need to plug it in. I need to plug it in because there are different situations that require different treatment. So when I plug in 1, 1 plus 5 is 6, 6 minus 6 is 0. 1 minus 1 is 0. So first we have to talk about such a situation. One more time, limits can have 0 over 0 situation, and I'm going to write what this means. There exists hope. that the limit exists. So there is hope that the limit might exist. Another situation is a number, any number, not zero, over 0. This one, there is no hope. Absolutely no hope that the limit exists. Absolutely none. What are the options for this? So a number divided by 0 has 3 options: infinity, negative infinity, or D and E. Are there other options? Yes. And they are for later use. Okay? Other, they are called indeterminate cases. This one is an indeterminate case. This is one of them. So there are a total of 7. 7 indeterminate cases. I'm going to list just a couple more that will be, we will see them in this class. So 0 over 0, infinity over infinity, infinity minus infinity, and so on and so forth. And some powers, like infinity raised to 0, 1 raised to infinity, something like that. So when it comes to limits again, we can have basically an indeterminate case. All of these have hope. I just didn't want to add them in there because this is what we are discussing right now, a situation of 0 over 0. So basically there are 2 major possibilities. An indeterminate case that has hope. I'm not saying that the limit exists. I'm not saying that. I'm saying that all these indeterminate cases, the limit in all these might exist. I'm not saying it exists. But I'm guaranteeing the limit does not exist. And these are the possibilities as answer: infinity, negative infinity, or D and E. So, coming back now to our problem, I want to mention one more thing from probably, I hope, from your past, but it doesn't matter. I'm going to mention it here. So, I'm copying the problem one more time because I wrote so much I need to copy it. If you notice, the numerator is a polynomial, the denominator is a polynomial, and there is something called the factor, and there are 2 different things, and remainder theorems. Why I'm presenting this in short to you is because I would like you to understand what really happens here. Every time I get 0 over 0, when I plug in a number, so if I have p of x, and I plug in 1, for example, it's because it's 1 here, doesn't matter, 4, and I get 0, what this means is that x minus 4 is a factor of p of x. Mandatory. If I plug in p of negative 3 and I get 0, this means that x plus 3 is a factor of p of x. And now you could say, fine, beautiful, but how is this connected to this? It has a huge connection to this. Because I plugged in 1. I know what is the problem. The numerator has to have a factor of x minus 1, and the denominator must have a factor of x minus 1. And that's huge. Understanding that this happens is huge for what's next. So don't write it here, it's not part of the problem, but I just want you to understand. So I'm continuing here. Knowing that, I write x minus 1. Because I plugged in 1 and I got 0, x minus 1 has to be a factor of the top and it must be a factor from the denominator. All I have to do is just match the rest. So this must be x plus 6. And this must be x plus 1. There is no other way. So now I am removing the problem. I am removing the problem or the culprit. What is the culprit? Right here. This was the problem. That gave 0 over 0. Knowing that, I plug it in. The numerator is 7, the denominator is 2, and the limit exists.